Created by MindSticks Foundation Trust.
Welcome, students! Today, we are going to learn an absolutely brilliant algebraic shortcut. But first, let's just quickly glance at our agenda for this explainer. We'll be looking at the graphical method, the limitations of graphing, what a determinant actually is, introducing Cramer's rule, and then summarizing the steps to solve these equations.
Right, let's dive straight into Section 1, the graphical method, where we will be reviewing the coordinate plane.
Take a close look at this graph. You know, it's incredibly satisfying when our intersection points for x and y land on perfectly neat whole numbers, isn't it? Points like 2, 1, or -4, 4. When the numbers align perfectly like this, solving equations visually is just a breeze.
But that brings us to Section 2, limitations of graphing. What happens when the mathematics is not so perfectly neat and the numbers get messy? Well, look at the challenge right here in this Let's Think section. You'll see coordinates like 1/5 or -11/3. Now these are definitely not your simple everyday whole numbers, are they? Think about it for a moment. Trying to mark exactly 1/5 on a standard piece of graph paper. It's incredibly tedious. It leaves far too much room for human error. One tiny slip of your pencil and boom, your entire solution is rendered completely incorrect.
Which perfectly leads us to Section 3. What is a determinant? It's a remarkably clean mathematical tool.
Simply put, a determinant helps us take a grid of 4 numbers and boil it down into one single, neat numerical value. As you can see, it's a value represented by elements arranged symmetrically in rows and columns, and we calculate it using a very specific, simple formula: A times D minus B times C.
Notice those diagonal arrows. That is the core of the operation right there. To find the value, we simply cross-multiply. We multiply the top left element A with the bottom right element D, and then from that product, we just subtract the product of B and C. It really is a beautiful, systematic little pattern.
Let's actually walk through this first solved example together, shall we? We have determinant A. 5 times 9 is 45. Then we multiply 3 and 7, giving us 21. 45 minus 21 gives us a neat whole number, 24. And look at that. We solved it without needing a single sheet of graph paper.
Now for the fun part. Section 4. Introducing Cramer's rule. This is all about solving equations easily and in much less space.
The absolutely crucial first step here is how we set up our problem. We must ensure our equations are perfectly aligned. They absolutely have to be written in standard form. That means keeping the x and y variables firmly on the left side of the equal sign and completely isolating the constant c on the right. Getting this formatting right is literally half the battle.
And the best part? We don't need to memorize any heavy, lengthy algebraic derivations. Not at all. Instead, we simply need to construct 3 specific determinants. We'll call them capital D, dx, and dy.
This next part brilliantly illustrates the logic of mathematics. Notice what's happening here. For the main determinant d, we only use the columns containing the coefficients of our variables, x and y. We just extract those numerical coefficients and leave the alphabet variables completely behind. Simple, right? Here is a very quick logic check for you. The absolute easiest way to remember this substitution method is this. When finding dx, we simply hide the x column and replace it with our constants. And it's the exact same logic for dy. Just hide the y column and swap in the constants.
Look closely at these exact substitution rules. They clearly lay out how the coefficient columns, a1, a2, and b1, b2, are neatly swapped out for the constant c1, c2. It's a highly systematic process, meaning there is absolutely no guesswork involved.
Let's bring it all together now in Section 5, Steps to Solve Equations. This is your fail-proof method summarized. These are your 3 golden steps. Step 1, align the equation exactly as ax plus by equals c. Step 2, calculate the numeric values of your 3 determinants, d, dx, and dy. And finally, Step 3, just divide to find your variables. X equals dx divided by d, and y equals dy divided by d. I want you to take a mental snapshot of this Let's Remember flowchart. It is literally the perfect visual summary of Cramer's method. If you just follow these simple arrows, you are going to successfully navigate from the problem to the correct solution every single time.
But before we wrap up our explainer today, who exactly was Gabriel Cramer? Let's look at the history behind the math. Well, this phenomenal method is named after the Swiss mathematician Gabriel Cramer. Born in Geneva, he was such a remarkable scholar that he actually earned his doctorate at the age of just 18. Can you imagine? His brilliant structural thinking is exactly what saves us so much calculation time today. So here is a question for you. The next time you're faced with tricky fractional numbers, what will you do? Will you painstakingly draw a complicated graph just hoping your pencil marks are perfectly exact? Or will you use the precise, elegant logic of Cramer's rule? I truly hope you choose the power of determinants. Keep practicing, my students, and mathematical excellence is absolutely within your reach.